our discussions on the topic of stepper motors. We already started in previous class. We defined the stepper motor, what is the stepper motor and how it works. And we discussed the advantages and drawbacks. And as we said, it has minimal 8 advantages and just 2 drawbacks. So in general, the advantages are superior to the disadvantages. So this is very good. Also, for the types of stepper motor, we said that we have 3 different types: permanent magnet one, variable reluctance one, and hybrid. And we started in discussing the variable reluctance, and we covered or highlighted the applications. We discussed also that variable reluctance stepper motor has many designs. It's not fixed design. Like for instance, when we discussed synchronous machine, we said that synchronous machine, we have 3-phase stator winding at stator, and we have field winding supplied by DC at rotor, for instance. Okay, but here, this type of machine, the stator winding is not fixed connection, it has many shapes, and the rotor has no windings and has many shapes for poles, so or for teeth. So the design here is very, or has many shapes. It's according to your application and required motion. We discussed also the operation and discussed the step angle. Step angle relation is ns minus nr over ns nr multiplied by 360. So this is going to give you the full step angle in degree. Okay, and this is an example here for 6-teeth stator and 4-teeth rotor. And for the full step operation, it will be 30 degrees. Also, we discussed the full step operation. So, and this was the last thing we discussed previous class. In order to recognize the full step operation or the operation for any stepper motor, first we said that the first signal or the first position will be assumed. So the first one, we assume that we have step number 1, where coil 1 is energized and other 2 coils are de-energized. And as we said here, we have 6 stator teeth, and we assume that the H2 opposite teeth has 1 coil. So when you energize coil number 1, these 2 teeth, this teeth and that teeth will be energized. So this is the rule in this design now. In order to understand how the motor will move, we will apply the second step and compare it with the first step. So if we apply now step number 2, which means coil 1 will be de-energized, coil 2 will be energized, and coil 3 will be de-energized as well. In order to understand the full step operation or the motion of our motor, we should compare to the first case. First case here, we have this rotor teeth is facing teeth number 1 here, like that. And this teeth here, as we discussed, it will be shifted, or it's now shifted from teeth number 2 by 30 degrees. Why? Because this angle now between the two successive teeth of rotor is 90 degrees, and the angle between teeth 1 and 2 is 60 degrees here. So 90 minus 60 is 30 degrees. So when we energize coil number 2, it's expected that flux is going to move in this way and will continue in the outer core of the stator. So for now, Shabab, we discussed that we have 2 different characteristics important in the operation of stepper motor. First characteristic, as you can see here, the flux lines will prefer to move in the core itself, not in the air gap because the we can say reluctance of the core, okay, is less than the reluctance of the air gap. For that, it will be preferred to move in course. This is the first characteristic. Second one, the flux lines all of time will try to short their path. How? By moving this core in order to make flux line as straight line in Shabab. So if this happens in Shabab, you will find that this tooth now will be directed in this direction here and will face the other tooth here, like that. Now, comparing the rotor position here in the second case with the first case, you will find that the rotor has moved for 30 degrees. Is it clear, Shabab? First step, is it clear now?
Yes.
Fine. Now the question, if I would like to move the coil for another 30 degrees, which coil should be energized and other coils should be de-energized? ها شباب مين يقول معايا؟ ها. Now we are in this position and we need to move the motor another 30 degrees in this direction.
The second coil.
Already second coil now is energized. So coil number 2 is energized. Which coil should be de-energized and which coil should be energized? اتفضل يا هشام.
1 and 2 should be de-energized and number 3 should be energized.
تمام. Very good. Because as you can see يا شباب, now the angle between this tooth and stator tooth is 30 degrees. So if you would like to move the rotor another 30 degrees, you can energize now coil number 3 and de-energize coil number 1 and 2. So the step after step number 2, step number 3 will be like that. Coil 3 is energized, other coils are de-energized, and the rotor will move also another 30 degrees. طب now يا شباب, we finished step 1, 2, and 3. As you can see يا شباب, here we start 1, 0, 0, then 0, 1, 0, then 0, 0, 1, and we move now only 60 degrees. In order to complete the cycle, we need to repeat the sequence again. So steps number 1 to 3 have to be repeated for 6 times in order to move the motor for 360 degrees. Yani we moved already 60 degrees in 3 steps, and we need to move the other 360 degrees to complete 1 rotation. Okay, so we will repeat this these steps 1 to 3. We will repeat these steps another or 5 times again. For that, you will find that we have steps from 1 to 12 in order to reach to 330 degrees. And 330 degrees, شباب, the position of the rotor will be 30 degrees before this one. So if you apply step after 12, شباب, 1, 0, 0, we will return back again to the position at this figure. So it will be one complete revolution. So step number 13 will be the same as step number 1, which is the reference or 0 degree. So this table represents one complete revolution. Okay, شباب, one complete rotation of our motor. تمام يا شباب? Is it clear? طيب. So this is now شباب called full step. If you apply the relation we already discussed last class, it's the same number of tooth, 6 and 4, so you'll find theta is 30 degrees. Can we move this motor يا شباب in values different to 30 degrees? Is it possible?
Yes.
You mean
the teeths?
How we can do that يا شباب? With the same design, without changing this design. I mean, we will keep the motor stator 6 teeth, rotor 4 teeth, okay? But can we change the sequence of pulses in order to move this motor in a step different to 30 degrees? This is first question. Another question, how we can reverse the rotor motion? Now, with this sequence, as you can see, the motor rotation here for all of cases will be in clockwise. What will be the sequence, شباب, if we would like to operate the motor or rotate the motor in counterclockwise? Let's discuss the second question first, شباب. The rotation direction. How we can reverse the direction? مين يقول يا شباب؟
by changing the sequence.
استنى انت شباب, you solved already or you answered some questions, let some of your colleagues to participate with us. مين اللي كان عايز يقول يا شباب تاني؟
Yes, I just said reversing the sequence of the pulses.
Reversing the pulse sequence. So can you let me know what should be the sequence now? Firstly we started with 1, then 2, then 3. So what should be the sequence in order to reverse the motion?
1, 3, 2.
1, 3, 2. Let's see together, شباب, if we apply the pulse after 1, instead of applying pulse to coil number 2, we can apply to coil number 3. Let's see if we apply now coil number 3 to energize coil number 3 here. So this means this coil will be energized and this one as well. So you will have like N and S here, okay? And in this case, you will find this tooth is displaced from this tooth by 30 degrees. And this is displaced by 60 degrees. In this case, شباب, when you energize coil number 3, the rotor will move in the counterclockwise in order to make these two teeth face to each other. To keep it in the same axis. In this case, you are right, it will be reversed. So you can reverse the motor motion by changing the sequence of pulses. طبعا شباب, here in this example we have only 3 coils. We may have 4 coils, 6 coils, 8 coils. But the same way, if you change the sequence of pulses, it will reverse the motor operation, the motor direction. So this is the answer on question number 2. Regarding the first question, we said, now we have the same design. Can we move the motor with a step angle different to 30 degrees? And how?
Yes.
If yes, what is the angle that we can move the motor firstly, and then how we can apply this motion?
The maximum is half of the full step.
So we can move our motor by only 15 degrees.
Yes.
How we can do that, شباب? How we can do that?
Energizing step by step, moving from 2 to 1, for example, by energizing 2 coils.
ممتاز. This is actually the way how we can make half step operation. So شباب, this is half step. Let's understand it together. طبعا first position is the same like in the full step operation. We will apply coil number 1, 2 and 3 will be de-energized. Now, if we would move the rotor in a distance or mid distance or mid angle of full step, we should apply two coils energized at the same time. طب let's return back to the full step operation شباب. Can you see here the sequence at steps 1 and 2? At 1 we have 1 0 0. At 2 we have 0 1 0. If we make ORing for these two pulses, two sequence of pulses, you know OR gate يا شباب, is it right? OR gate, it means 1 plus 1 equal, or 1 or 1 equal
1.
0 or 1 equal
1.
0 or 0 equal
0.
0. So in order to move our motor in half distance or half displacement of full step, you should apply this sequence 1 0 0. Let's go together to the half step. As you can see here, we will apply 1 1 0. Sorry, 1 1 0. Okay, 1 1 0. Let's see now if we applied 1 1 0. So this means in the second step we will have two coils now energized. طب here شباب, طبعا again, in order to understand any step operation, you have to recognize it from the step in previous case. This is now our initial case شباب. Now if you energized coil number 2, as you can see, the shift or the angle between this tooth and that tooth is 30 degrees. And here the angle is 0 between coil or tooth number 1 in stator and this tooth in rotor. If you now energized coil number 2, طبعا coil number 2 يا شباب will need to move the flux lines in the core and will try to short the distance. And the same is also for coil number 1. Coil number 1 يعني need to make very short distance as well. This is يعني is the same flux line characteristics. So يا شباب, because we have two different coils, there will be like back and forth between the two flux lines up till moving the rotor in equidistance to be in equal displacement for each tooth. So this means the rotor will move in this direction and will keep distance of 15 degrees away of each stator tooth. Okay, شباب? So this is the way now. For now, the flux lines will not be straight like in case of full step. Yani flux lines will be like that. And the other one here will be like that. It's not straight like in case of full step. However, the distance between or the displacement between the stator and rotor teeth are equal. We have here 15 degree apart from that side and 15 from the other side. So there is stability now, or the operation now, or the motor now is stable. This is called the شباب half step. طبعا if you now de-energize coil number 1, you will move another 15 step, which is the same as step number 2 in case of full step operation. تمام يا شباب؟ Is it clear؟ ها في أي سؤال يا شباب بخصوص الهاف ستيب؟ يعني half step operation is clear now؟
I have a small question.
اتفضل يا شباب.
This is the only option we can go through it. I mean, can we increase the angle, or it should be just we have two options?
لا, for a certain design,
yes,
using this motor, you have only two options: either full step operation or half step operation. Actually, we have one thing called micro step operation. However, this type of micro steps cannot be applied for variable reluctance in this design. And based on this design, it's impossible. So يعني the angle or the stepping angle can be changed or made according to our motor design. For that, we said firstly, in order to design the motor, you have to make your يعني criteria. You need certain step angle, you need certain speed, okay? You need certain torque, and after that, make your own design based on your step and torque and so on. So, in terms of step angle, this will be affecting the number of a stator and rotor tooth. This is very important, okay? And after making your design, you have only two options now, either operating at full step or half step. Okay? Is it clear, Hisham?
Yes, it's clear.
Okay, good. Any other question, Shabab, regarding the operation of half step? Again, if we would like now to reverse the motion, طبعا simply, similar to the full step operation, just change the sequence. So instead of 1, then 1, 2, then 1, like you can make it as 1, 1, 3, then 3, and so on. So, يعني reversing the sequence can reverse the motor direction. This is the way of reversing the motor direction. طبعا يا شباب يعني here we just filling some tables. It's not a game. How we can physically reverse the motor motion? يعني what is the system that will be used in order to translate these tables or this schedule into motor operation? This is what we have to understand. We are electrical engineers, not just writing on papers. You have to understand how you can already make programming and apply this sequence of pulses in order to achieve the motor operation. So inshallah we will discuss it in details when we reach to the power circuits used in each type of motors. Okay, and we will discuss the practical aspects related to stepper motor. I believe شباب most of you inshallah if you did not make your graduate project yet, or you're still thinking about the point of graduate project, and if you have something moving in electromechanical motion, stepper motors are widely used. So it will be a good chance for you to understand the stepper motors. So we have now some important notes, and we already covered. To reverse the motor direction, شباب, the sequence of pulses has to be changed. For example, instead of 1, 2, 3, it will be 1, 3, 2. This is number 1. Note number 2, for the full step operation, only one coil is energized. As you could see in the lookup table for full step operation, at each instant or each step, you have only one coil energized. However, as you can see here, first step we have one coil, second step we have two coils, third step you have one coil. Right. Is there any issue if we make this sequence of pulses? Let's see this important notation. So to operate the motor as half step, you need to follow the following sequence: 1, then 1 and 2 together, then 2 only, then 2 and 3, and so on, and repeat the sequence. So we have now theta half step equals half multiplied by theta full step. And in this case, شباب, the steps per revolution will be S. So S is the steps per revolution. طبعا it's all of time equals 360 over theta. So if you have theta equals 30 degrees, so you have 12 steps. If you have theta equals 15 degrees, so number of steps will be 24 steps in this case. تمام شباب. The important note regarding energizing in different ways, instead of having all of time one coil, we have sometimes one and sometimes two coils. Half step has drawback, so we have here a problem of pulsating torque. This is the issue now with half step. When you apply one energizing coil, you will have a certain value of torque. And when you apply 2 coils energized, you will have higher torque. And according to the sequence of pulses, it will be repeated. So the torque shabab will be like that. The highest value will be if you energize 2 coils, and the lowest value will be when you energize 1 coil. So the flux now is pulsating, or you have ripples in flux, and the torque as well. Because if you have ripples or pulsating flux, the torque will be pulsating as well. Tamam? So this is now considered as one of the drawbacks of the half-step operation. Regarding the motor speed, shabab, how we can calculate the motor speed? Simply if you multiply 60 by F over S. 60 multiplied by frequency, where F is a frequency, shabab, or we can say it's number of pulses per second. Okay, so number of pulses per second, shabab, will give you multiplying frequency by 60, okay, because we have 60 seconds in 1 minute. So this is the relation, or from where the 60 came. So 60 multiplied by F over S, because we need to calculate number of revolutions, not per second, but per minute, RPM. So it's 60 multiplied by F over S. This is now the relation, how you can calculate the motor speed. The drawbacks of variable reluctance type is the smaller torque compared to permanent magnet and hybrid types. So this is now as introduction. You will find in permanent magnet and hybrid motors, the torque will be higher. طبعا يا شباب يعني this is expected, because here in variable reluctance you have energized poles in stator and just piece of iron in rotor. You don't have any flux or any magnets in rotor in order to establish a high value of flux or strong flux. For that, you will find torque is very small in case of variable reluctance motor. However, for permanent magnet motors or hybrid, because hybrid collects the advantage of variable reluctance and permanent magnet, you will find the torque values and flux as well are strong, or torque values are high compared to the variable reluctance one. Regarding the typical steps shabab used in industry for variable reluctance stepper motor, you can find angles, low or small stepping angles up to 1.8. Okay, this is the values or typical values of variable reluctance stepper motor in industry. Okay, so these are some important notes regarding the operation of variable reluctance and the evaluation for the performance of the variable reluctance. Now regarding the power circuits, we said we have some sequence of pulses and we need to operate the motor based on these pulses. How we can translate these pulses, shabab, into the real operation of a stepper motor. For instance, assume we have here 4-phase, 8 stator teeth and 6 rotor teeth, like that. So for the 8 stator teeth, we assume to have 2 opposite teeth with 1 coil. So we have now coils A, B, C, D. How we can make a circuit in order to move this type of motors? Simply you have the coils like that. We have now 4 phases, A, B, C, D. And the energization is nothing but connecting this coil to a supply and flow a current in this coil. So we need to move current in these coils in order to be energized. Simply we can use electronic switches, shabab, or power electronic switches like IGBTs, like MOSFETs, whatever. And based on the controlling pulses, which should be implemented with a microcontroller, for instance, and you have to implement the lookup table we have shown in the previous slides, okay, in order to operate the motor in the required performance, تمام, and apply these pulses to the switches like that. So for 4-phase motors like that, we need 4 switches to move the current in one direction. As you can see, current here can only move in one direction. So this is here an example, and this simple circuit discusses how you can make the circuit of variable reluctance. Okay. Let's compare the machine torques of any design, شباب, in order to be clear how we can increase the motor torque. Simply, in the structure here, we have A, B, C coils repeated for teeth, as you can see, A, B, C again, and so on, repeated 4 times. So you have now 12 teeth in stator, okay, and in rotor 1, 2, 3, 4, 5, 6, 7, 8. We have 8 rotor teeth. Here, the node 3-phase 12 teeth motor, step angle here, if you calculate the step angle, it will be 15 degrees. So in this case, شباب, how many switches we need if we are going to make it in 3-phase? Regarding the previous circuit like that, if we have 3 phases, so this means how many switches we are going to use?
I think 3.
3, تمام. So we need to use now 3 switches. This is right. طيب, let's compare this design now. This design with the other design here. We have coils or stator teeth firstly, 1, 2, 3, 4, 5, 6, 7, 8. So here we have 8 teeth. It's not 12 again. Four phases, not 12 يا شباب, this is 8. Step angle, because the number of rotor here, teeth 1, 2, 3, 4, 5, 6. So 8 teeth and 6 teeth for rotor. Step angle will be the same. You need also 4 switches. However, this type can deliver higher power. This one can deliver higher power. Why, شباب? Why this one can deliver higher power?
I think because the number of phases.
Here we have 2 windings, okay, or 2 energized coils. تمام? And the rotor is coupled only from 2 portions, not 4 portions like that. Okay? لا هو كده الكومباريزون يا شباب is not valid. لا معلش يعني neglect the comparison between these 2 types. لا يعني we cannot compare this one with that one. معلش, I disagree with the reference here in this comparison. Here these 2 are the same, صح? These are similar design يا شباب. So let's compare between these 2 only. يعني we have here again 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 teeth in the stator and 6 teeth in the rotor. So we can now compare these 2 designs together. طبعا the step angle يا شباب is the same because both of them are similar. تمام? Here we have 2 teeth in one coil. Okay. Here we have the same number of phases A, B, C, D. However, we have, as you can see, coil A here is connected to this tooth, but A and B are energized together. As you can see, A here is energized and B is energized at the same time. تمام يا شباب؟ So if I have more coils energized يا شباب, and assuming we have equal coil resistance, which means the same current can flow, so in this case you will have higher power in this motor. So the power here will be higher, especially if it is working at half step. يعني at half step operation, at the portion of supplying the motor from 2 coils, in this case you will have much more torque and much more flux. So this is going to make the power high here. So neglect the comparison with this one because the number of tooth are different. So just consider شباب this a comparison, and I will remove it in the updated version inshallah. So from here we can see that if you apply 2 different coils at the same time, this means the rotor itself will be coupled from here and here as well, which means higher torque compared to this portion. Now it's only coupled from 1 or 2 portions instead of 4 portions. So you can find that the power here at this stage is higher than the power at this case. So if you operate the motor at half step, it will have higher power compared to full step. Okay, so this is شباب one of the operation. But by the way, if we energize each time 2 coils, not 1 half coil, let's return back again to the operation here. يعني instead of having يا شباب steps 1, 2, 3, 4 like that in half step, we can use 3, then 5. We are going to omit 4. Sorry, not 3 and 5. We can use 2, 4, 6, and so on. So here in 2 we have 2 coils. In 4 we have 2 coils. In 6 we have 2 coils, and so on. So is it going to move now in 15 degrees or 30 degrees يا شباب in this example? 30. تمام? Because here it was at 15 degrees. Here it became 45, so the difference is 30. But each time you apply signal for 2 coils together, so this means you have higher power now. تمام? So for the same motor, according to your sequence of pulses, you can increase or decrease the power. Based on what, شباب? Based on your control now. So here, either operating this at full step or half step, it will be higher in power compared to this A design. تمام يا شباب? So we can control the power or torque by controlling the energized coils. Now regarding the
regarding the losses, the
yes,
losses will be higher in the step in half step operation.
والله يعني losses in this type of motors, طبعا firstly these motors power are very small. يعني the expected losses we have here, we have some copper loss, which is I square R. Okay. Core losses are very small. ماشي. You have طبعا يعني this motor has special operation. It's not working يعني for all of time, so friction losses is different a bit here in calculation. تمام. يعني it's not that high like other motors طبعا because the motor is small. However, mainly the losses will be in copper. So if you applied the half step operation, you will have both high power and high losses as well. However, all of time losses are very small compared to gained power. تمام. So comparing if you have half step operation with full step operation, the losses at half step will be higher than the losses at full step. However, the power itself in half step will be higher than the power at full step. Okay.
Okay.
Now, شباب, this is needed as homework. Okay. Design a variable reluctance stepper motor that can move with a full step of 2.5 degrees. So I need all of you to start thinking what will be the number of stator and rotor teeth that will provide 2.5 degrees. After that, you should answer the following question. What is the motor speed if the number of pulses frequency or number of pulses or frequency is 5 kilohertz? So this will be the switching pulses frequency. So what will be the motor speed in this case? It depends on your design now. Propose a power circuit for your design. What will be the power circuit according to number of phases, number of tooth, and so on. Draw the machine section showing the operation for 2 successive steps, like what we have made, شباب, in our examples here. I show you now 4 steps. So I need a section, but not handwriting, شباب. Use tools in order to draw the motor sections. ماشي? 2 successive sections. If you would like to make it on computer and print it out, no problem. Or even you don't need to submit hard copy. You already submit soft copy. So if you would like to draw the structure itself or using any program on computer, it's possible طبعا. So we need only 2 steps, شباب, in your homework. تمام. So we need first step and another step, but it has to be a successive step. So step number 1, next will be step number 2. If it's step number 3, the next should be step number 4, and so on. And you need also to fill the lookup table for 1 complete revolution. So write the lookup table of the sequence of pulses for 1 complete revolution. تمام شباب. So this will be inshallah homework number 4. ماشي. طبعا for the universal motor you will submit the take home exam. Okay, and here for stepper motor this will be the homework of stepper motor. ماشي شباب.
دكتور.
تفضل.
2 successive steps, you mean like you only need 2 steps, like I didn't quite understand the 2 successive steps part.
Stop, let me repeat the discussions again. Here, I said draw the machine section showing the operation for 2 successive steps. In order to understand the operation here, when we discuss the operation, we already show the motor section for 2 steps. Is it right?
Yes.
And this was the first position, and when we moved the motor to the second position, it moved like that. تمام? So in order to understand your design, you have to draw at least 2 steps.
Okay.
Okay, you got it. So I need just to draw 2 steps of the A, and not all of the steps, whatever the number of steps, or 4 or more. Just 2. Okay, just to show how the motor will move. Is your design practical and working in the proper way or not? This is just what we need from the design. تمام.
So
is it clear, شباب?
2 steps mean 2 positions?
Yes, 2 steps. It means 2 different positions طبعا. And it has to be successive steps. According to your schedule, your lookup table. تمام. يا شباب, is it clear? طيب, the time, regarding the time, شباب, طبعا time is very limited now. So we have a time until I think next week only. So today is Sunday, so next Sunday شباب will be the deadline for this homework. And it's only one design problem, it's not a lot of problems like any ordinary homeworks. So inshallah 1 week, and I expect to have it inshallah from you next Sunday by end of the day. Okay شباب?
Sorry, Doctor, what is LUT means?
LUT, which is the lookup table. Lookup table we already made here in order to show the steps. This is the lookup table.
Okay.
Which means that the sequence of pulses for the operation. تمام. طبعا يا شباب يعني this lookup table should be applied on digital controller, microcontroller, for instance, and it will be delivered to the switching elements here in order to operate the motor according to your design. ماشي؟ And for that we give the name of sequence of pulses as lookup table because it's يعني regularly implemented in digital controllers as lookup table. Any other question, شباب? Everything is clear?
Yes, Doctor.
يا شباب نشوفكم ان شاء الله في الكلاس القادم. السلام عليكم ورحمه الله وبركاته.
دكتور.
وعليكم السلام. تفضل.
دكتور